Welcome to VINDAL'S concept. Let's solve this problem. You said a milliammeter of resistance 5 ohm and a full scale deflection of 50 milliampere is to be measured. A potential difference of 50 volts. What should be the resistance of the multiplier? Now look at this. The issue is that when we talk about a multiplier, we are talking about an instrument which is boosted with a high resistance wire connected in series in order to measure a voltage. I said that when I talk about multiplier, I'm talking about a galvanometer which measures a very low voltage. Now, you connect a high resistance wire in series with the galvanometer that will help you to measure a higher voltage, and that is what is called a multiplier. So in this case now, I have this wire, this resistor, and then we have a galvanometer. So this is the multiplier. So in this case, what happens? This is the galvanometer. Now, it means that there is a current flowing in to the multiplier, and the same current is going to be flowing out through the galvanometer. That current is the same throughout because it's a series. Because in the series circuit, the same current flows through the wire. Now, what happens here? There is a resistance of the multiplier and there is a resistance of the galvanometer, because this one is the galvanometer. Now, what do we do? First, I have to first of all measure the voltage across the multiplier, which is Vm, and also measure a voltage which is across the galvanometer, which is called Vg. Now, what is going to be the total voltage? Therefore, the voltage of this plus the voltage of this is going to give me the total voltage that this system can now measure. And that is why I'm going to say Vt is going to be Vm plus Vg. This is the equation that helps you to solve a problem on galvanometer. That means the voltage of the multiplier plus the voltage of the galvanometer is equal to a total voltage. Now, what is the total voltage? Vt is going to be equal to the current across the multiplier times the resistance of the multiplier plus the current across the galvanometer times the resistance of the galvanometer. If you notice this, you realize that the same current is flowing through all of them. The same current is flowing through all of them. So I'm going to have that Vt is going to be I bracket Rm plus Rg. This is it. So, and this is what I'm going to use to solve any problem. Now, going back to the question we have, a multimeter of resistance 5 ohms. That means Rg is 5 ohms. Then, and the full scale deflection of, that means the current flowing through them is 50 times 10 raised to the power minus 3a, which is something like 0.5 ammeter. Can we prove it? Because this is 5 times 10 raised to the power 1 times 10 raised to the power minus 2. Okay, sorry, this is 0.05 milliampere. Because this is going to be 5 times 10 raised to the power minus 1. No? So this is 5 times 10 raised to the power 1 times 10 raised to the power minus 3, which is 5 times 10 raised to the power minus 2 ampere, which is something like 0.05 ampere. This is the current that is flowing through the circuit, because there is only one current that flows through the circuit. Now, what is the next thing? A potential difference of 50 is to measure, that is the total voltage is 50 volts. So what should be the resistance of the multiplier? I'm looking for Rm. So I'm going to use this first formula, which will help me. So this is 50, for this Vt is 50, I is equal to current, which is 0.05 times resistance of the multiplier, which I am looking for, plus current is constant, 0.05 times the resistance of the galvanometer, which is 5. So I have 50 minus 0.05 times 5 is equal to 0.05 times Rm. So this is going to be 50 minus 0.25 is equal to 0.05 times resistance of the multiplier. So 50 minus this is going to be 50.00 minus 0.25. This is 9, this is 10, this is 5, this is 7.49. So everything is going to be 49.2.75 is equal to 0.05 times resistance of the multiplier. So the resistance of the multiplier is going to be 49.75 divided by 0.05, which is something as, let's use this. You have 49.75 divided by 0.05, which is given as 995 ohms. And looking at the question there, you see it in option C. Thank you. Please make sure you make a comment, like, share, and very importantly, please subscribe. If what you are seeing is good, please, I want to beg you to subscribe. Thank you for now, and meet me in the next class.